Hello and welcome to helpyourmath.com. In this video, we're going to look at the fundamental counting principle, specifically focusing on factorials. So factorials. Certain types of counting occur more frequently, such as possible arrangements of a given number of objects. So for example, if I had 5 different candy bars, how many different ways could I consume the 5 different candy bars where I have one right after the other? For any counting number n, the quantity n factorial is given as, so we would say that the number of ways, so I said candy bars, I could eat my first candy bar and I would have n options to choose from. Once I consume one, now I have n minus 1 to choose from. And then n minus 2, and so on, so I'm going to say dot, 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 until I get down to 3 possibilities and then 2 possibilities and 1 possibility. So we would say that when there's n objects and I'm trying to do something, arrange them or eat them or whatever, the factorial would be n times 1 less than n times 2 less than m, and all the way down. And the notation that we use for factorial is we say n factorial. It's a very excited n factorial. Let's look at some examples. So we want to evaluate 4 factorial. This is not 4 exclamation point. It's not a really excited 4. It's 4 factorial. So 4 factorial would be 4 times 3 times 2 times 1, which would give us 24. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1, 5040. And 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which would be 3,628,800. 3,628,800. So this is how we can evaluate factorials without a calculator. In your calculator, you might be able to find it, but I'm not going to tell you where in case your teacher doesn't want you to know. Sorry. All right, so let's use factorials. How many ways could the letters of PAL be arranged? So in this case, there's 3 to choose from because it's a 3-letter word. So we can have 3 possibilities for the first, 2 possibilities for the second, and 1 possibility for the third, right? So this is 3 times 2 times 1, which is the equivalent of 3 factorial, which would be 6. Another application of factorials, 7 friends attend a movie together. There are 7 seats for them to sit in. How many ways can the 7 friends be arranged in these seats? So again, what this is looking at, we have 1, 2, 3, 4, 5, 6, 7. 7 possibilities for the first seat, but once somebody's sitting now, there's only 6 possibilities for the seat next to them, and then 5, and then 4, 3, 2, 1. So this is the equivalent of 7 factorial, which I think we already calculated to be 5,040. So if there's 7 people, there's 5,040 different ways that these 7 people could be sitting in 7 seats that are consecutive, which is kind of crazy to think about, right? Okay, in our last example, I reach into my wallet and pull out all of my money. My wallet is empty. Sad day. How many ways can I pull out my money? So this is an important one because this is saying I have nothing to pull out of my wallet. So what does this mean? What does 0 factorial mean? Well, how many ways can I pull nothing out of my wallet? There's one way, and that's to pull nothing out of my wallet. So while normally when we're talking about factorials, we are talking about positive integers, we do include 0 here, just so that nothing breaks down in the end, and 0 factorial is considered to be 1. So for factorials, we would say 0 factorial is 1, which is kind of like the weird one. 1 factorial is 1. 2 factorial is 2 times 1, which is 2. And then 3 factorial is 3 times 2 times 1, which is 6, and on and on and on. So the only weird one that we see is 0 factorial. This has been a quick lesson on factorials. Thank you for stopping by.